Okay, so we have this problem that's asking us to see if these points, distance and the cost in dollars, can be represented by the linear function z equals 2.25d plus 1.5, where d stands for distance in miles. So we have Matt and Jing's solutions to this problem. So for Jing, what he starts by doing is he starts by finding the slope between 2 points that's given in the problem. So here he uses 12.75, which is the cost for that trip, and 8.25, which was cost for another trip, over the miles for those specific trips, and he gets the slope, which is 2.25. Then what he goes on to doing is getting the one of the totals. So in this case, he uses 26.25, which is the third point, and he sets up an equation where it's c minus 26.25 equals 2.25 times d minus 11. So he has the cost and the miles that is related to that specific cost. He goes ahead and distributes the 2.25 to d and 11, and you're left with c minus 26.25 equals 2.25d minus 24.75, and ultimately he solves the equation to get c equals 2.25d plus 1.5. What Matt does in this case is he goes ahead and gives the points that's given in the specific problem, so 3 miles, 5 miles, and 11 miles. And what he does is he goes ahead and gives the equation that we're asking is true, so 2.25d plus 1.5. But instead for the d, he goes ahead and substitutes 3, 5, and 11. And that's how he gets 8.25, 12.75, and 26.25, which relates to what we were given in the problem. Now for Matt, one of the things that I would recommend for him is not necessarily automatically assuming that that relationship c equals 22.25d plus 1.5 is correct, and we can't just assume that once we plug in all the points and we get the same thing that's in the problem, that's it, because something else could change in the situation. So that's the only thing that I would bring out for Matt in this specific case. Me personally, I would rather go with the process that Jing used to solve for the equation by finding the slope, plugging in a point, and specifically solving to see if that works. One of the things that I want to commend for Jing is his breakdown of the problem, essentially showing every single step. For me, I was able to say that step 1 is, he solved for the slope, and that's how he started creating his own linear function, because he used the form y equals mx plus b in this case, so he was solving for m, which is the slope. Also, what I like that he did is he used all 3 points to show that the relationship worked. Some students might think that's a little bit confusing because they just like to work with consistency, but specifically the way that Jing did it is showing that all 3 points that were given in this problem do work and they do create the same slope. So I do commend him on that. Some of the things that I would recommend for us going over this problem is possibly coming up with another mileage. So example, we're given 3, 5, and 11, maybe solving for 1 mile or solving for 4 miles, somewhere in between, to see if the relationship is kind of going in a linear section. I think what would raise a red flag is if we got something that was out of the 26.5 range, and maybe it, for example, being a 28 or a 28.75 or something like that for 4 miles. I think that's a little bit too extravagant, and that's something that we can prove by using the linear representation. For Matt, I think he was going on the right track, but I would like to see a little bit more of what he was doing, in the sense of, were you thinking of something else that told you, if I just plug in the values 3, 5, and 11, that's what I'm gonna get. If he was maybe taking a shortcut and not explaining his thought process because he knows this since it's a review and he understands what it means to be a linear function and the relationship that it's causing. Other than that, I think both students should be commended for their work, in the sense that they both reached the same answer. However, like I said, I think Matt took a step too further and didn't break down every single thing. He just automatically assumed that the relationship that was given in the problem is correct, and he just showed that if you plug in the values 3, 5, and 11, you do get the same answer that was given in the problem in his solution. I think if he goes a little bit more depth, then that way he can understand where the relationship is coming from, and he understands that the linear function is in truly 2.25d plus 1.5.